We'll come back around to homework questions here in a little bit. What we're looking at and starting today is solving quadratics, solving quadratic equations. We're trying to find out what value of x will make the function equal 0. And that's the main thing we're going to be doing and looking at with solving quadratics. Now, there's going to be multiple different methods that we're going to look at with solving quadratics. Some will work better than others, and we'll see them as we go through them. Now, we're going to solve them by graphing and algebraically. And today, really, we'll look at graphing and using the square root method, as well as factoring. We'll get to factoring tomorrow, but mainly graphing and using the square root method. Now, for us, a quadratic equation in one variable is an equation that can be written in the standard form, ax squared plus bx plus c, where a, b, and c are going to be real numbers. Any number, it could be positive, negative, it could be fractions, it could be decimals, except a cannot be 0. A cannot be 0. If a is 0, the number in front of x squared is 0, well, it's just going to be 0. So we wouldn't have the ax squared term, which would just leave us with our bx plus c. So it would just be linear. It would not be considered a quadratic. So the ax squared term is really what defines this to be a quadratic. We need the x squared term for it to be considered a quadratic. Now, the first one we'll be looking at is solving these by graphing. And really what we're looking for is the x-intercept. We're trying to find out what value of x will make the function equal 0. Well, that's really our y value, because when y is 0, the whole function is 0. It's equal to 0. So if we can find out what x value will make the y 0, or the x-intercept, because the x-intercept, the y value at any x-intercept is always 0. So if I can find the x-intercept, I will find the value of x that will make the function be 0. So when we look at this here, when we graph, we're just trying to find the x-intercepts. We're trying to find where the function here, x squared minus x minus 6, crosses the x-axis. Now, if we were doing this by hand and wanting to graph it, well, we'd start out by finding the vertex and then going one point to either side to see, do we eventually hit a spot where it equals 0? But what we can also do is we can use the graphing calculator. So we can graph it using the graphing calculator, and that will give us the exact same thing. So what we can do is we can turn the graphing calculators on, guys. And we can go on and type that function in. So we're not going to type in the equals 0, but we can type everything else in. So our first function, we would type in x squared minus x minus 6. So we'd turn it on and hit y equals, and then type the function into the first place. And once you get the function all typed in, go on and hit graph. Any questions on how to get the function typed in? So that'd be x squared. Any other questions on how we got this typed in? We all able to get it typed in? Go on and hit graph. And it'll graph the function. Because again, when we're trying to solve these, we're trying to see where these equal 0. What value of x will make the function equal 0? Or give us a y value of 0. So we're looking at the x-intercepts, where it crosses the x-axis. And so how many times, Caleb, let's focus up here. How many times does it cross the x-axis? Twice. There's 2 spots where we get a y value of 0, yes? Now, it might be a little hard to read here, so what we can do is go second, graph, and look at the table. Now on the table, we can use the up and down arrows to move it up and down to see where do we get a y value of 0. Well, one of them is when x is -2, because when x is -2, the y value is 0. And we can also see right here at when x is 3, the y value is 0. Because again, we're trying to see what value of x will make the function equal 0, or what value of x will make the y value be 0. So the x values that we're looking for are -2 and 3. Questions on this here? So that means for this here that the solutions, x would equal -2 and x is equal to 3. And that's it. Now we could check it to make sure, because if you're not 100% sure that you got the right answers, it just doesn't feel right. We can always plug them back in. So what we could say is that -2 squared minus -2 minus 6. Because I can plug this into a calculator and check it to see, does this equal 0? Because if this equals 0 or gives me a true statement, then it did work. Well, here -2 squared is 4. -2 would be +2 minus 6. Well, 4 plus 2 is, and 6 minus 6 is 0. Is that what we wanted it to be? Yeah. So it means that -2 is a true solution. We could do the same thing with 3 and say 3 squared minus 3 minus 6. Well, 3 squared is 9 minus 3 minus 6. Well, -3 minus 6 is -9, and 9 minus 9 is still 0. So both of those work. And really, that's one way that we can check it, is just plugging the numbers back in and seeing, does it give me 0, or do both sides of the equation equal out? Any questions on this here? Let's look at the next one. -2x squared minus 2x equals 4x. So this one here is a little bit different than the previous one. How so? There is a number in front of the x because we have 4x, yes? It equals 4x. We don't have 0 on either side, do we? Because when we worked with factoring last week, solving it by factoring, we had to have the thing equal to 0. For really any higher degree polynomial function where we have a variable to a power greater than 1, so x squared or x cubed, we want everything on the same side. There are a few exceptions, but this here, when we're dealing with these, we really want everything on the same side, so we can subtract 4x from both sides. Because 4x minus 4x here would be 0. And what that would leave us with is -2x squared minus 4x minus 2 is equal to 0. Because 4x is not a common factor or like terms with our 2x squared or the 2, we just put it in the middle. Any questions on this here? Now again, we're wanting to solve this by graphing, yes? And we have this equation equal to 0. So what we can do is we can get the graph. We would have to actually go on and get points. So start with the vertex, or -b over 2a, and go from one side to the other. So if we have the graphing calculator, we can go on and plug it in. So I clear it out and then go on and plug in the new function, -2x squared minus 4x minus 2. Now, whatever number goes first, so our 2x squared, we'll want to use the negative sign in front of it, but the others, the 4x and 2, we want to use the subtraction. If we use the negative signs in front of them, it's going to assume multiplication. And once we get that typed in, you can go on and hit graph. Any questions on typing this in? We can go on and hit graph. So where does it cross the x-axis? Well, it doesn't quite cross it, does it? But we do see kind of an intersection right here. Yes? So let's go on and look at the table. And the way we can get the table is second graph. So at -1, the y value is 0. So we know that -1 is a solution for this here. Now every quadratic will have two solutions. They just might not be unique solutions. Because for here, there are two solutions. One of them is x is equal to -1. Does anybody have a guess of what the other one is? That would be -1. Because whenever it touches the graph, it doesn't actually cross it. It's said to have an even multiplicity, an even number of zeros at that spot. So here, there are two zeros or two values of solutions, or two solutions at the spot x equals -1. There's an even number of zeros there. There's an even number of values of x that will make the function equal 0. Well, here we'll get into more of it next chapter of exactly why we know it's exactly 2, because there's only two solutions for a quadratic function. So here there's 2, but I mean for higher degrees we could have 4, we could have 6, 8. There could be multiple zeros there. Now, really, even though that there's 2 there, we can still write the solution as just x equals -1. We don't have to write it twice. We can just write it once. Any questions on this here? There's a graph. All right. Turn the page. There we go. So the next one we have is x squared minus 8x plus 12 equals 0. We want to solve it by graphing. Well, the function is already equal to 0, yes? So we can go on and grab the graphing calculator, hit y equals, and go on and type the function in. So we can say x squared minus 8x plus 12. So we can go on and type the function in and hit graph and see where does it cross. So it does cross in two places, yes? So where does it look like it crosses? And we can double check it by looking at second graph. It would be at 2 and 6. Positive 2 and positive 6 would be our two solutions. So we can come back over here and say x is equal to 2 comma 6. This will also work because they're both x equals. So we can write out x equals 2 and x equals 6, or we can do it this way here. Both of them will work. Any questions on this here? Let's look at two more. Let's look at this one here and then the next one. So these last two, and then we'll move on from here. So what's the first thing that y'all see that we need to do? Right, we need to get it equal to 0, so we can minus the 1/2 x squared. From both sides. Because the 1/2 x squared minus 1/2 x squared would be 0. Now there's no like terms with our 1/2 x squared, so we'll leave it in front. Now I didn't say this earlier, but it did hold true earlier. If we were factoring this, the next thing we would do would be looking for greatest common factors or trying to get the term in front of x squared to be positive. Because when we did the factoring, we would factor out a negative or try to make it positive, yes? Does the calculator really care if there's a greatest common factor or if the term in front of x squared is negative? No, it can do it just fine. So we don't have to worry about that. So if we're going to do it by hand and factor it, it might be easier to get the negative, the term in front of x squared positive. But the calculator, it really doesn't matter. Now we can go on and type it in. Because we can say negative alpha y equals, enter, 1 over 2 x squared plus 6x minus 20. Because we have this function here. Yes. Alpha y equals, enter. Alpha y equals, enter. Y equals, yep. Clear? Yep, and then alpha y equals, enter. We'll give you the fraction. Now you could do the fraction of the negative 1 on top. That'll be the same as having the negative out front. It will give you the exact same thing. You can go on and hit graph, and where does it cross the x-axis? Nowhere, right? So since it doesn't cross the x-axis at all, the solution would be what? No real solution. So is there an actual answer that we can find? Yes, the actual answer would not be what? It wouldn't be real. Because there is a solution for this. It's just not real numbers. It's going to be imaginary. No, there actually is such thing as imaginary numbers. We'll cover it later this week. But this will have a solution. We just cannot find it by graphing. Because the only way that we can find solutions by graphing is if it crosses the x-axis. This one doesn't. So there's not going to be a solution for it that we can find by graphing. There is one, but we'll have to use other methods. This here's the last one we'll look at by graphing. 4x squared minus 12x plus 9. Well, I can pull the graphing calculator up again. Figure that out. 4x squared minus 12x plus 9. We got it typed in. And if we hit graph, it crosses the x-axis, or well, it intersects the x-axis at what number? Well, it's kind of hard to see here, isn't it? So let's go second table, see if that tells us where we have a y value of 0. No. But going back to what we covered in last chapter, we do have an axis of symmetry that goes through the vertex, and every point to the left and right of it would be equal distance from it. And we can see the mirror images in the y, because we have 1 and 1, 9 and 9. So most likely the vertex will be somewhere between 1 and 2. But since that's most likely going to give us a 0 somewhere between 1 and 2, it means our x value, the solution, is a decimal. We would have to manipulate the scale on this here to see what it is. Or I already have it graphed out over here. It works out that the solution for this here is 1.5. So the x value for this here, if we wouldn't found it, would be x is equal to 1.5. So that would be not too bad, because we'd have to change the scale from whole numbers to halves, and then we'd be able to see it. But really what I'm getting at with this here is that decimals, because if we have irrational numbers and non-repeating, non-terminating decimal as a solution, it's going to be very difficult to find it by graphing. So graphing works very well if we have whole number answers, or 1.5 wouldn't be too bad. But once we get to a little bit uglier, quote unquote, uglier decimals, graphing doesn't work too well. Graphing works well if we have whole numbers, because it just shows us what the answers are. So that means we're going to have to go to other methods to find it if the solution isn't a whole number. Now, one of those methods is the square root method. The square root method is very specific in how we use it, in that it has to be set up in one of two ways. The first is that x squared is the only variable that we have. That we don't have any variables, it's just x. We don't have like the middle term in our standard form on either side. So we wouldn't have like 49x or negative 31x. Because x squared is the only one here, we can use the square root method. The other setup is this here, where we have x inside a set of parentheses squared and no other variable anywhere else. Then it would work here. But it's very specific to these two cases. Now, it is possible to get a standard form into a set of parentheses squared and then work it that way. It's a little bit more work to do that. But we'll look at this one here. 4x squared minus 31 equals 49. And what we're going to use is the square root method to solve it. And the reason that we know that we can use the square root method is because x squared is the only variable. We don't have a variable that's just x, and we can use this here. Now, the first main step in the square root method is to get the x squared by itself. So what's the first thing we can do to get x squared by itself? We can add 31. There's here 31, negative 31 plus 31 would be 0. Which will just leave us with 4x squared equals 80. What can we do next? We can divide both sides by 4. 4x squared divided by 4 would be x squared equals what do y'all think we would do next? We'd use a square root, yes? Well, what's the name of the method that we're using? The square root method. So it means we're going to have to use a square root at some point. Well, the square root of x squared is x is equal to plus or minus. So whenever we take the square root of both sides, we're going to have to include the plus or minus. Because a number is squared, x squared, because if it's negative, negative times a negative is a positive. A positive times a positive is also a positive. So when we take the square root of both sides, we have to include that plus or minus. So if we just try to take the square root of 20, we do see that it's an irrational number. Because the numbers like, so, well, 1 squared is 1, doesn't really tell us much. 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25, yes? Well, 4 and 5, 5's too big, 4 is too small for 20. So it's not going to factor completely. But if we look at the factors of 20, for perfect squares, well, 4 times 5 is 20, yes? Well, what's the square root of 4? 2. We can't take the square root of 5. So we get that x is equal to plus or minus 2 square root of 5. Now, the graphing calculators, it is possible to get them to do perfect squares or to simplify it into radical form. But I've looked into it, and it revolves around a lot of graphing multiple functions, or the two functions, and seeing where they match and see where they meet up. And it's a little bit more work than it's worth. Because especially on the ACT, if you're having to simplify into simplest radical form, which would be 2 square root of 5, the yellow calculators, the TI-30XS, will do it just fine. You can type in square root of 20, hit enter, and it'll tell you the answer. It'll tell you that it's 2 square root of 5. If you hit the button above enter, the 2 arrows, it'll convert it over into the decimal for you. But it'll do it for you. And we have this here. Questions on this? Now, even though it does have a radical in it, 2 square root of 5 and negative 2 square root of 5, we can still plug it back in like we did with the first one, and it would still give us 0, even though it does have a radical. Questions on this here? Let's look at this one here, 3x squared minus 9. So since there's only an x squared, there's no x term, we can still solve this by the square root method. Well, what can we do first? Add the 9 to both sides. And if we add 9 to both sides, we get 3x squared equals 9. And then what? Divide both sides by 3, which tells me x squared is equal to 3. So we did these steps here really to get x squared by itself. And last but not least, we can do what? Square root both sides. Well, the square root of x squared would be x is equal to plus or minus. Is 3 prime? Because prime means it's only multiplied by 1 in itself. So 3 is prime. Well, that means it's just square root of 3. Because whenever we take the square root of a prime number, it's just going to be that square root of that number in simplest radical form, or we're just going to find the decimal of it. Any questions on any of this here? All right. I know that there is still more to the lesson. We'll cover those tomorrow. Because what I do want to go back to is homework questions. I do know that there's at least one that we want to look at. So that's it for today. And I'm going to look at at least one of the homework assignment problems from 3-2. I think you just wanted to see the first one. Yes. Yes. Number 4. You remember what it was? Oh, okay. So Michelle, when you see the one you want, we'll cover that here. So 2k squared minus 5k minus 18. Now the first thing we would look for is the greatest common factor. Well, 2, 5, and 18, there's not. So 2 sets of parentheses with 3 spaces. Guys, keep the volume down just for a bit. We'd have this here. Now because the 18 is negative, our signs are going to be opposite. One's going to be positive and one is going to be negative. Then we would look at the factors of the first and third term. Well, k squared is going to give us k and k. Well, 2 is just going to be 2 and 1. Because that's going to be the only factors of 2k squared. So the worksheet. Mhm. Now, the factors of 18 are 1 and 18, 2 and 9, 3 and 6. Guys? 1 and 18, 2 and 9, 3 and 6. So we need to pick one of these that we think might work best. And looking at this here to give us 5, well, 9 and 2 look like it might work best, so 9 and 2. Erase this here so we can check. Because if we check this here, 2k times negative 2 would be negative 4k. Guys, again, thank you. 9 times k would be plus 9k. Well, negative 4 plus 9 would be positive 5k. Is that what we wanted? Well, no, we wanted it to be negative. So what we can do is flip the signs because we got the correct number but wrong sign. So we would change the 9 to be negative and the 2 to be positive. Because now that would work. Because it would give us plus 4k minus 9k, which would be negative 5k. Any question? Does that make sense how we got the two factors? And now since we have two things multiplied together to equal 0, it means that one of them must be 0. So we can set those two factors equal to 0 and solve. So here we can add 9 to both sides. Those will cancel, telling us that 2k is equal to 9. Divide both sides by 2. And k is equal to 9 halves or 4.5. Either one works. On the other side, we would subtract 2 and say k is equal to negative 2. Any other questions on those there? Number 8. Yeah. Yeah, they'll both, we can look at 8. Because the first main step in both of them will be about the same. Well, for the other one. Here, as we talked about today, briefly, is that we do need this thing equal to 0. So we're going to subtract 6 from both sides, which would give us 6n squared minus 18n minus 24 is equal to 0. Now, we could factor out the greatest common factor or divide by it as long as it's not a variable. Here, we can divide everything by 6. Since it's just a number for the greatest common factor, we can divide it out. So 6n squared divided by 6 would just be n squared minus 3n minus 4 is equal to 0. And once we got rid of that greatest common factor, we can go on and continue on with the factoring that we've done before. Since the third term is negative, our signs are going to be opposite. One's going to be positive, one's going to be negative. It really doesn't matter which one we put as positive and negative. We just have to pick one for each. Now we can look at the factors of the first and third term. Well, the factors of n squared are just going to be n and n. That's only one set. Now 4 is 1 and 4 or 2 and 2. Which one do we want? I'm going to go with 1 and 4. Because with different signs, if it was 2 and 2, they would essentially cancel out. And if we check it, it would work because we would have negative 4n plus n is the negative 3n we wanted. So we'd have n plus 1 is equal to 0 and n minus 4 is 0. So we can solve by subtracting 1 from both sides and then adding 4 for the other. Which would give us negative 1 and 4. Mm-hmm. Sometimes it's just those little things. Any other questions on this here? Finish with that one? These here? 6x squared.
Minus 5x.
Mm-hmm. Y'all have a good rest of your day. I'm going to still finish this. So 6x squared minus 5x minus 1. There's not a greatest common factor between any three, because 1 there's not going to be. Oh. Yes. So 2 sets of parentheses with 3 spaces. We'll move on to this here. Now, since the 1 is negative, the signs are automatically going to be opposite. Now, we'll look at the factors of 6x squared and 1. Well, the factors of 1 are just 1 and. The factors of x squared will be x and x. So the real thing that we're looking at the factors of 6, which would be 1 and 6 or 2 and 3, because it's going to be one of those two. And that's what we need to figure out. So at this point, we just need to pick one of them and work with it. For just time's sake, I'm going to say 6 and 1, because we know that we're going to subtract. And if we check it, well, 6x times negative 1 would be negative 6x. 1 times x would be plus x, and negative 6 plus 1 would be negative 5x. So at this point here, we can just say 6x plus 1 is equal to 0, and x minus 1 is 0. And then we would solve and get that x is equal to negative 1/6, or x is equal to 1. So if you want to, because this will be posted in the video, so you can go back and double check it to make sure that you did get the right numbers.